Alrighty, time to start another or continue a streak. Feeling pretty good. It's 396, so it's probably an easier one because it's one earlier ones, maybe. Rotate function medium. You're given an integer array nums of length n. Assume array k to be an array. Assume array sub k to be an array obtained by rotating nums by k positions clockwise. Define the rotation function f on nums as follows. F of k is equal to 0 times array sub k at 0. Interesting. The rotation function multiplies the elements of the array by their index, multiplies the value by the index, and takes the sum of those products. Return the maximum value of f0, f1. 4, 3, 2, 6, 26. What is going on in f0? Return the value, the maximum value of f0 to f of n minus 1, where n is the length. So there's 4 possible things here. Okay, so you apply it. So the first time is 0 times 4, 1 times 3, 2 times 6, 3 times 0 times 4, 1 times 3, 2 times 2, 3 times 6. Add those up. And then shift. Is shifting it 6, 4, 3, 2. Where in this is it talking about shifting the elements? Obtained by rotating nums by k positions. I see. Okay, so if you're rotating these things by k positions, then there's going to be at most n positions it can rotate through. So like 4, 3, 2, 6, and then 6, 4, 3, 2, and then 2, 6, 4, 3, right? 2, 6, 4, 3. Okay, yeah. 0, 3, 2, 6, 4. Okay. Okay. Okay, so the length is 10 to the 5th, so they want something faster than n squared here, which obviously would be what I would start with if I were to brute force it. So the question is, what is the way to simplify this calculation, or some shortcut to... What is going on here? Why is... It doesn't seem like there would be a pattern. Like, how is the f0 related to f of 3? Four, 3, 2, 6. 6, 4, 3, 2. 2, 6, 4, 3. And 3, 2, 6, 4. Oh. So the weights are always there. The weights are always there. So the weights are always going to be 0, 1, 2, 3, up to n minus 1. Is there a way to search it? Is there a way to search it? The test case is generated so the answer fits in a 32-bit integer. Nums, the values can be from -100 to 100. Guess it could repeat here, right? Obviously, if there's only 201 different values, and it could be multiple thousands length, so it has to be repeating in some fashion. Or by the pigeonhole principle, it has to possibly repeat if the length is like 202 or more. There has to be some sort of way to leverage the rotation. I don't know about that. If I leverage the rotation, I'm pretty much going n squared, kind of, because I'm rotating n positions for n positions, and then probably have to do n kind of subparts to the calculation, so it'd be n squared. So it's kind of not rotating it somehow, but then still somehow figuring out which one is best. Still figure out somehow which one's best. 4 times 0, 1. So it's basically doing a dot product. Is there a fast dot product thing that I can do here? I don't know. Is there a fast dot product in Python? NumPy. So I do a vector. Like, how fast is this dot product? Unlike pure Python loops, which are implemented line-by-line, NumPy uses vectorization. This allows it to perform operations on entire arrays at once using compiled code, bypassing overhead of the Python interpreter. For massive datasets, you can use GPU-accelerated libraries like Coopy, I'm not sure how to pronounce that, which implements dot products on graphic cards. Medium to large arrays, 40 to 100 times faster. What is it doing? Why the gap is so large? The speed difference comes down how the computer handles the data. In a regular loop, each number is a full object. In compile speed, when you call np dot, you aren't running Python code, you're using highly optimized C or Fortran code. I mean, I wonder, I probably should test this just in case. Probably should test it just to see the speed difference, to be honest. So obviously it's a dot product, or obviously if I make a vector that's like 0 to n minus 1, do the dot product of that versus converting the array to some vector, or make a vector 0 to n minus 1, convert nums into n different vectors by rotation, and then find the highest dot product. Alright, I'm just going to do it just to see what it's like. Okay, I haven't done much of NumPy. NumPy. Is it pronounced NumPy? Is NumPy pronounced NumP or NumPy? Oh, I guess I've been mispronouncing it. NumPy. I mean, it looks like NumPy to me, but I'll go with NumPy. Anyways, NumPy, I need to see converting sample code to convert integer array to NumPy vector. Okay. np.array passing the array variable. Okay. So let's go ahead and create I'll call it the base vector, and that'll be NumPy, or I guess it'd be NP, but whatever. I guess it's already imported. It's probably already imported, but whatever. np dot, is it vector again? Or is this array actually? Array, I'll just do a list comprehension here. K for k in range of n, where n is the length of the nums array. And that's the base vector. And then I guess I need to do it. Ooh. How would I do the other one? I have to do every single one. Oh, whatever. I can't. That's disgusting. Can np array take a double-ended queue? Okay, so it can take just a collection. Okay. Good, good. Let's go ahead and create the double-ended queue from the nums array. That'll make it easier to do the rotation, because I can just pop from the left side, append to the right side, or vice versa. I guess is it vice versa? Pop from the right, append to the front, append to left. Anyways. So for every, I guess I need to have answer equals 0 for every something in range n. So just do this n times. What was the multiplication thing again? I'm just passing a and b. Use np dot or at. Legacy support np dot. Their difference between using np dot versus at performs broadcasting. It treats higher dimensional arrays as stacks of matrices and multiplies them accordingly. np dot performs the sum product of the last axes of the first array and the second to last axes of the second array. This often results in completely different output shapes than you'd expect in standard matrix math. Scalar multiplication. At does not allow multiplication by a scalar. np dot allows scalar multiplication. Okay, I guess it doesn't make a difference if it's both one-dimensional vectors. So, I'm not going to care about this stuff. Actually, do I need to convert? It's the return value of np dot a int, or does it need to be converted? I think this might need to be converted. np dot returns entirely on the data type of the inputs. It does not automatically convert. Yeah. Yeah, I need to convert to int, I think. So result is, let's see the array. The other vector is going to be equal to, I probably shouldn't call it vector. It's kind of like a type. I'll call it vec. Vec is going to be np dot array vector of the deck, and then the result is casting to an int. I'll just use np dot base and the vector, and then answer equals max of answer and the result. And then I need a pop left or pop right. So last. I wonder if I can just say deck dot append, or I think it'd be called append left is my guess. Append left deck dot pop. Deck append left. I think that's the term, or that's the function. Yeah, so that pushes to the front wherever I took off the back side of the double-ended queue. And I think that might be it. Okay, so that works. Question is it still too slow? Is This is basically n squared if this operation did take. Oh, shucks. Interesting. Why would it have gone wrong? Zero? Oh. Whoops. Whoops. It could be a negative number. The answer could be negative, considering that you're adding a bunch of negative stuff. But it can't be so far negative as to be negative infinity. Whoopsie. It's pretty bad logic by my part. Setting in the answer. Oh, that's just when one of the test cases probably made it 4 seconds, and that test case was number 34. This can time out almost certainly. But I'll just verify it that it times out before I go ahead and chalk this up to the waste bin. Yep. Okay. Well, it's good to know that this is a thing in terms of faster vector multiplication. Just not fast enough considering well, they obviously didn't want you to use this. Okay, anyways, let's go back. 4, 3, 2, 6. 6, 4, 3, 2, 2, 6, 4, 3, 3, 2, 6, 4. So is it heaps? Is it heaps? So close. In general, you'd want to use your biggest number as your back-end value. Your biggest number as your back-end value. Be more precise. You can't just have a wavy, you can't say like the sum of these values or something, and so therefore you want these values further back. Can you do some sort of sorting? Then a greedy approach just doesn't work. I don't think. You can't just say that your biggest number is going to be your last number in the rotation, even if that gives it the highest weight. So you can't. Tricky. Can't calculate everything. Can't calculate everything, otherwise, like, yeah, I just tried calculating everything. You can't do that. So you want to do some incremental calculations and somehow eliminate things. Either eliminate things or never compute things based on the fact that some partial calculation already eliminates that possibility. Some partial calculation already eliminates that possibility. Hmm. A, B, C, D. 0, B to C, 3D. And then rotate 0, A to B, 3C. Rotate 0, C, 3A. 4. Yeah, I forgot the 4. 1. No, there's no 4. Just be 2 here. 3B, 0. This is obviously wrong. D. C, 2, D, 3A. What's the pattern? And then comparing these. Comparing B, 3C, or B, 2C, 3D versus A, 2B, 3C versus D, 2A, 3B, C, 2D, 3A. 0, 1, 2, 3. 0, 1, 2, 3. 1, 2, 3. Hmm. How do you do this comparison of all these dot products without actually fully calculating all the dot products? Wonder if I have to leverage the fact that it's actually between 100 and 100 and negative 100 each value. Each following number has a higher coefficient by 1. Each following value has a higher coefficient value by 1. Oh. This is a long list. It is a very long list. Like, there's n rotations to the list, where n can be 10 to the 5th. So just like printing out, literally printing out using for loops, each value in the list is going to be n squared, or in all the lists that it can go through is going to be n squared. But then you want an answer that is actually faster than that to do a calculation on those values. That's pretty impressive, gotta say. Pretty impressive. Optimization. Someone pretty smart came up with this question. Maybe. Or someone pretty smart came up with a question and someone smarter came up with the answer. So you have some arrangement of the values. If I were compare two adjacent values, what is the difference? What is the delta? So let's say this is x and this is y. What is y minus x? Y minus x will have 1c, 1b, 1a, and minus 3d. Interesting. Feisty. Yeah, okay. So if this is, let's say, x again, and this is y again, this is y minus x, and that's going to be a plus d plus c minus 3b. A dc minus 3b. Okay. I think that should be the answer somehow. It's the difference between the rotations. Difference between the values of the rotations is like the sum of all the values in the original array minus 3 times, or n minus 1 times the last value. Sum of the first n minus 1 values minus n minus 1 times the last value. So then I just need to calculate. I just need to calculate it once and then cycle through. Okay. Tricky. So let's say answer is 0. And then it'd be something like, I calculate initial value. So let's say it's I do need something called the sum, or let's say the total is going to be sum of nums. I do need that. And then it needs to be something like, I need to calculate initial value. So for every something in range n, answer plus equals, I wonder if I should use the dot product here just to make this part faster, because it Okay, let me do it the slow way and then maybe try to do the NP to speed up that first calculation. Oh, answer is not going to equal 0. Well, yeah, answer equals 0, so that's fine. Answer plus equals I guess I do need the index here. It equals k times nums at k. So it calculates the dot product. And then the first rotation, so what does it do here? The first rotation, I'm adding the first 3 elements and subtracting the last element. So again, for every, I guess I'll just do this in order, huh? Let's say current equals the answer. For every, I guess I should probably just do this backwards, k in range. Minus 3D. This thing minus this thing is minus 3. Okay, so k in range n minus 1 to the start decrementing, then current modifies by, so this is the same thing as c plus b plus a plus d minus 4d, like d minus 4d is 3d, where c plus b plus a plus d is the total minus 4d, where total is going to be the same thing as total minus n times the last value. So that's the generic way of doing it. And that's the difference between the totals of the rotations, the value of the rotation functions. So it should be plus equals total minus n times nums at k. And then I say answer is equal to the max of answer and that current value. Okay, I think that might be right. All right, took 4 seconds last time for that, and now it takes 0 milliseconds. Okay. Very interesting. All right, I was gonna try to do NP, use the NumPy dot product to do this initial calculation for the first dot product, I think. So I think it should probably be answer is equal to something like integer np dot, I'm just gonna make a really complicated function here, np array of nums and np array of like k for k in range n. I think that works. Well, we'll see shortly. Okay, let's see if this is any faster or slower. Okay. Way to ruin the fun. Code. Leetcode. Way to ruin the fun. Alright. Alright, well, at least I kind of get the syntax for the NP stuff. NPy stuff. I guess I should probably, this is fine, right? Current equals answer. Maybe it should be answer. There should be maybe current, actually. And then say answer equals current here. It's a little more logical in some ways. Although, why does it seems like it's doing like an extra calculation in my mind. I think it could stop at 0, to be honest. Pretty sure. It doesn't, because the last calculation just goes back to the first one. I'm pretty sure. Lane current total. Yeah. Okay, whatever. Same deal. Okay, so I guess really if anyone looks at this and wonders what the heck is going on, it's just basically this stuff right here. If they've taken algebra and they've understood mostly that, then they should be able to understand what the hell is going on based on just looking at that. Okay. So summary, look at the above algebraic pattern between algebra pattern when calculating the difference between, what are these things called, function values, between rotation function outputs. There is a fairly consistent shorthand. There's a fairly consistent, easily calculatable value that the difference is a fairly consistent, easy calculate value. Thus, calculate the initial or starting rotation function, i.e. f of 0. Then calculate f of 1 by doing f of 0 plus the delta equals f of 1, where delta is, in general, the sum of the nums array minus n, where n is the length of the array times the last value. Similarly, track can calculate f of 2 is equal to f of 1. Well, f of 2 equals f of 1 plus delta, and so forth. Keep track of the highest value, highest function value, and return. And basically, if the calculation of 0 here is like 0a, right? 0a, 1b, 2c, this is the sum of these values. 0b, no, 0d. If you're adding these values for x and you're adding these values for y, and these are just one rotation off, the difference between them, which is like the delta, is going to be c minus a minus, like 3c minus 2c, 2b minus 1b, and a minus 0a, so it's going to be c minus b minus a. and then minus 3D, obviously. And you can go ahead and expand out 3D to be d minus 4D, so that you can therefore do c plus a plus b plus d is the same as the total of all the values in the nums array. 4 is just the generic, or in general, the size of the array, and d is just in general the last element in this array. So basically, when you do a rotation, the difference between the values of the rotation, x being the f of 0 and like y being f of 1, whatever, the difference between the values is the total of all the values in the array, well, minus the last value in the array times the number of elements in the array. And therefore, you'll have to actually like create the cycled array, cycled nums array, and then do the 0 times the first, 1 times the second, the dot product again, all over. Anyways, time complexity, this is going to be O of n, where n is the number of elements in the array, since the calculation of the delta is constant. The calculation of subsequent f values is constant, thus with n different f values, it'll take O of 1 times n, which is O of n time. Space complexity, this will also be constant O of 1, since no extra space is needed.